If you watch a typical mid-rise apartment building go up, you measure the progress in seasons, not days. A standard site involves coordinating hundreds of workers, heavy machinery, and an absolute reliance on wet concrete, which guarantees long, inevitable pauses just waiting for materials to cure. Then there is this, a 10-story building in China, stacked and secured from the ground up in exactly 28 hours and 45 minutes. When the crane dropped the final roof segment into place, it capped a structure that already contained finished interior walls, electrical wiring, and plumbing. This single project forces a re-examination of the traditional math of high-rise development, questioning whether the industry's standard multi-year timeline is a technical necessity or an inherited habit. This alternative arrives exactly when it is needed. Across the globe, we are facing an acute housing shortage, driven by surging material costs and a severe lack of skilled labor. This graph tracks the last 50 years of the construction industry. As you can see, the line representing overall construction costs rockets upward over the decades, while the line tracking actual labor productivity remains almost completely flat. Contrast that with how we manufacture modern consumer technology. Millions of highly complex smartphones are produced every single month, continuously becoming cheaper and faster to assemble. Even massive machines like automobiles are built rapidly inside optimized, climate-controlled factories. Yet houses are still constructed piece by piece, out in the open, highly vulnerable to the elements. The inefficiency is largely geographical. We stubbornly transport raw, unrefined materials to a muddy field to build, instead of doing the heavy lifting where it makes the most sense, inside a factory. The push to solve this problem didn't come from a veteran architect. It came from Zhang Yue, the founder of Broad Group, a man whose background was entirely in the air conditioning business. His focus shifted away from cooling systems after the 2008 Sichuan earthquake, a disaster that leveled entire towns and claimed nearly 70,000 lives. Surveying the damage, Zhang observed a stark reality. Traditional concrete structures possessed a fatal brittleness. When the ground violently shook, they simply snapped and collapsed. He proposed a structural theory borrowed directly from industrial manufacturing. He believed buildings should be engineered, tested, and assembled with the exact same precision as a consumer product. His initial goal was to eliminate the safety vulnerabilities of building in earthquake zones, but his method for achieving structural integrity inadvertently created a system built for incredible speed. Broad Group's solution was to physically drag the construction site indoors, replacing the muddy lot with massive manufacturing facilities large enough to cover dozens of football fields. They standardized the architecture itself. The entire building is broken down into uniform steel modules, designed to match the exact dimensions of shipping containers. While moving down the assembly line, these units are fully fitted out. Workers install the flooring, frame the windows, run the electrical wiring, and integrate the plumbing and AC. When a unit finally rolls out the factory doors, it is no longer raw material. It is a fully enclosed, standalone room waiting to be plugged into a larger matrix. Because the modules mimic shipping containers, transporting them to the final destination is a simple matter of loading them onto standard flatbed trucks. On site, the process shifts toward high-speed logistics. A crane picks up each pre-finished block and hoists it into its exact vertical position. There is no liquid concrete poured between the floors, which completely eliminates the need to wait for materials to cure. Instead, the units are secured using high-tensile steel bolts. As the crane lowers the module, thick industrial steel beams slide neatly into pre-engineered locking mechanisms, bolting the structural frame together with millimeter precision. By stripping away unpredictable weather delays and wet material curing times, the chaotic art of construction becomes a highly controlled exercise in vertical assembly. Which brings us back to the 28-hour and 45-minute record. Broad Group proved their methodology by stacking this 10-story apartment project in the Spratly Islands in little more than a day. As the time-lapse footage accumulated millions of views online, it ignited a fierce debate across the global engineering community. One camp looked at the footage and saw a scalable, immediate cure for the global housing shortage. The opposing camp dismissed the entire operation as a highly orchestrated and potentially dangerous stunt. The speed was so far outside the accepted boundaries of civil engineering that it immediately triggered a crisis of trust. People simply questioned if a building erected that fast could actually be legitimate. These modular structures serve as functional residential buildings, currently housing everyday tenants in fully finished apartments. The true hurdle here isn't mechanical, it's psychological. There is a deep, instinctual human anxiety tied to standing inside a towering structure that didn't exist 2 days ago. It forces a very uncomfortable question. No matter how perfectly the steel joints align, would you trust your own family's safety to a skyscraper assembled in a single weekend? Broad Group has proven that factories can solve the engineering bottlenecks of modern housing. Now, the final test is simply whether society is brave enough to step inside. An experimental 10-story building is an impressive prototype, but the obvious question is whether modularity can support the immense weight of true skyscraper heights. To test this, the company developed the Mini Sky City project. The design called for an immense 57-floor tower, capable of holding 800 apartments and office space for 4,000 people. They completed the entire 204-meter structure in just 19 days. This bar chart comparing labor and time isolates the efficiency of the method. During the Jingdu project, a crew of roughly 100 workers assembled 26 floors in a total of 5 days. Built the traditional way, that same structure requires hundreds of workers and approximately 2 full years. That breaks down to an average pace of completing 3 entire floors every single day. These metrics prove that modular mega-construction is a verified, scalable reality that is ready for global deployment. Operating at this velocity naturally invites investigators to ask if extreme construction speed compromises the safety and long-term lifespan of the building. Looking at this 3D cross-section, you can see the core engineering properties of Broad Group's steel frame. It is 10 times lighter than a standard solid concrete pillar, yet it possesses a stronger load-bearing capacity. This hollow, high-tensile configuration absorbs seismic energy by bending under pressure rather than breaking. It holds an official certification to withstand a magnitude 9 earthquake. There is also the environmental flaw of traditional construction. The standard concrete method generates mountains of unrecyclable debris and discarded materials that end up in landfills. The new modular system slashes construction waste by over 90%. Every structural component is designed to be disassembled and reused. The empirical data disproves the assumption that building fast yields a dangerous or disposable structure. The projected lifespan of these modules is approximately 1,000 years. Modular factory assembly is already highly efficient, but the next technological leap utilizes heavy robotics to 3D print entire architectural structures. This process relies on automated robotic extruders. They lay down continuous layers of fast-setting cement, which is blended directly from locally sourced recycled materials. This specific printing technology has already output 10 complete freestanding houses in exactly 24 hours. While Broad Group optimized the human assembly line to build skyscrapers, 3D printing introduces a reality where manual human assembly could be eliminated. All of this creates a central paradox. If this technology is objectively faster, stronger, and greener, every skyline in the world should be utilizing it today. Yet, while China built a 26-story building in 5 days, an equivalent project in London or New York still takes 3 years to complete. This diagram shows the invisible bottlenecks preventing global adoption. The new technology is trapped by zoning laws designed exclusively for 20th century materials. Traditional contractors and raw material vendors actively fight this to protect established revenue streams. The barrier to a global construction rollout is no longer a lack of engineering capability. It is resistance from entrenched economic systems. Broad Group's approach reaches beyond a 28-hour metric. It attempts to redesign the logic of the entire build process. Henry Ford's implementation of the assembly line drove down the cost of vehicles until they were accessible to the general public. Later, the standard shipping container revolutionized international trade because it forced all global infrastructure to adapt to modularity. The transition happening now is that buildings are no longer unique, site-built artisan projects. They are standardized, mass-produced industrial products. If this trend scales over the current economic roadblocks, the 21st century skyline won't be built on muddy construction sites. It will be manufactured cleanly and precisely inside factories.